More than 70 million sheep roam across some of Australia's harshest desert regions. For decades, they have been raised for meat and wool, while the land beneath their hooves has grown steadily weaker. Prolonged droughts have pushed over 220 million hectares of farmland into severe degradation. And when the land begins to collapse, it's not just crops that disappear. Food security and Australia's economic stability start to erode with every failed harvest. In desperation, the country tried every familiar solution to save the soil, from using more irrigation and more fertilizer to deeper land rehabilitation. But these measures only bought time. They could not reverse the damage, until attention unexpectedly turned to something long considered waste: low-grade sheep wool. So could sheep wool become the key to restoring fields that are slowly losing their life? People have grown used to seeing China at the top of global rankings, and this time is no different. China is currently the world's largest sheep-raising country, with around 194 million sheep. It is followed by India, where roughly 75 million sheep graze across vast fields and grasslands. But the name that makes many people pause is Australia, a country facing a widespread land degradation crisis, yet still raising more than 70 million sheep. So why does Australia need so many sheep? No, not to save the soil. That comes later. The real reason lies in meat and wool. In the 2024-2025 period alone, Australia exported 657,000 tons of sheep meat, more than 50% higher than a decade ago. But what matters even more is how they achieved this. Sheep farms in Australia produce 5 to 10 times more meat per hour of labor than most of the world. This efficiency is a critical advantage in a country where labor costs are roughly 10 times higher than in nations like China. Nearly 45% of the world's wool supply comes from Australia, a share large enough to make the country the global center of the wool industry. And it's not just about volume. Australian wool is also renowned for its exceptional quality. That reputation comes from the merino sheep, first brought from South Africa to Australia in the late 18th century, and gradually adapted to the country's harsh climate. The result is a fiber so fine, soft and durable, that many believe no natural or synthetic fiber can truly match it. While ordinary wool is commonly used for bedding and furniture, merino wool has become a symbol of high-end fashion, performance wear, and technical underwear. From sports apparel to luxury brands, Australian wool is everywhere in the global market. But then the picture began to change. After peaking in 2018 to 2019, wool prices collapsed sharply, falling to around 800 Australian dollars per 220 pounds, and have since only partially recovered to about 1,200 Australian dollars, still far from their golden era. As global demand declined, mountains of wool could no longer find buyers. For many farmers, the only option was to store and wait. But storage costs quickly became a growing burden. And here, a paradox emerged. What was once a source of national pride began to be discarded, simply to avoid further losses. Australia is not facing a price crisis alone. The country is witnessing two parallel crises, one of resource surplus and the other of biological collapse within the soil itself. Once home to more than 427 million hectares of agricultural land, Australia was long believed to be almost incapable of running out of soil resources. For decades, it stood as a symbol of prosperity across the southern hemisphere's grasslands, where livestock and crops helped feed global markets. But beneath that green surface, the picture is changing rapidly. Australia's land is not disappearing overnight. It is losing its ability to function year by year. In New South Wales, the agricultural heart of the country, soil organic carbon levels fell by 3.1% in just 14 years, from 2006 to 2020. This decline means poorer water retention, fewer soil microorganisms, and the loss of the biological foundation that crop root systems need to grow. In harsher regions, such as Western Australia, wind does more than carry dust. It strips away the topsoil, the most valuable layer of any agricultural ecosystem. At times, wind erosion has removed up to 1.8 tons of soil per hectare each year, soil that takes centuries to form, but can vanish after just a few dry seasons. Across the continent, many once fertile fields are slowly turning a scorched red, the color of desertification. More than 6 million hectares are classified as facing extreme erosion risk, while another 3.2 million hectares are severely degraded by water erosion. In Queensland, countless farmers have been forced to abandon land that once supported entire families simply because the soil can no longer retain enough moisture to sustain a full growing season. Now is the moment for sheep wool to be used to restore soil rather than end up as decoration in landfills. It may sound unlikely, but Australia has actually made it work. When scientists began testing waste wool in laboratories, they discovered something unexpected. The natural structure of wool fibers is almost pre-designed for soil restoration. Each fiber is coated with keratin scales, allowing it to hold 1.5 to 2 times its dry weight in water, while also creating countless tiny air pockets that let oxygen reach deeper soil layers. Exactly what Australia's degraded soils lack most. The results were not just theoretical. In early trials in New South Wales, applying a waste wool layer just a few centimeters thick reduced surface evaporation by up to 35%, while soil moisture remained nearly twice as high as with conventional organic mulches. This triggered a chain reaction. Within months, soil microbial activity increased by 30 to 50%, reactivating biological cycles that had been dormant for years of intensive farming. In abandoned fields in Queensland, where soil once cracked under extreme dryness, experimental wool mulches produced visible changes after just one dry season. Wind erosion slowed, moisture retention improved, and, most importantly, the soil structure began to recover. Instead of brittle red dust, the ground gradually returned to a loose, stable form, ready for cultivation once again. Despite the impressive early results, wool cannot simply be spread onto fields like ordinary fertilizer. The problem lies in the structure of the fibers themselves. In their raw form, wool fibers easily tangle together, forming dense mats that break down very slowly. In open field conditions, these wool masses can persist for long periods, blocking water from reaching deeper soil layers and slowing the entire restoration process. More importantly, raw wool decomposes unevenly. Some areas retain water for too long, while others receive almost no benefit at all. This runs directly against the original goal, improving soil structure in a stable, controlled way. To turn wool from a promising material into a practical solution, researchers had to process it differently. That led to 2 approaches. Wool pellets, designed to deliver water retention and nutrients directly into the soil, and wool compost, aimed at rebuilding soil biology over the long term. From that point on, wool pellets became the most effective way to deliver the natural properties of wool fibers into the soil in a controlled manner. Waste wool is ground down, compressed into pellets, and mixed directly into farmland. Thanks to keratin's ability to expand and contract with moisture, each pellet acts like a biological water battery, absorbing water when the soil is wet, storing it internally and slowly releasing it as the soil begins to dry. This mechanism allows soil to retain moisture 25 to 40% longer, significantly reducing irrigation needs under Australia's hot, dry climate. At the same time, wool compost serves as a long-term restoration solution. When wool is composted with microorganisms and other organic materials, keratin breaks down slowly, steadily releasing nitrogen, sulfur, organic carbon, and essential trace minerals. Within just a few months, soil microbial populations increased by 30 to 50%, laying the foundation for a soil ecosystem that can regenerate itself rather than depend on chemical inputs. Beyond nutrients, wool compost also improves soil structure and thermal retention, helping plant roots better withstand prolonged heat stress. In multiple trial sites, adding wool compost increased crop yields by 12 to 18%, without any additional chemical fertilizers. The impact of sheep wool does not stop at the field. As the soil begins to recover, another shift quietly takes place. The wool industry, once trapped in crisis, starts to restructure itself. Wool fibers that were once seen as a burden, costly to store and dispose of, are now becoming raw material for an entirely new market. In 2024 alone, the state of Victoria recorded more than 40 startups focused on recycling and processing waste wool, creating around 2,500 new jobs in rural areas, regions that had been hit hardest by the decline of the traditional wool industry. Wool is no longer priced solely by the volatile fashion market, but increasingly tied to the stable demand of agriculture and soil restoration. Economically, this shift is transformative. From every 1 ton of waste wool, facilities can produce nearly 900 kilograms of wool pellets, a product worth roughly 3 times more than raw wool. What was once discarded to avoid further losses has now become a core link in a multi-million-dollar value chain, sustaining an entirely new business ecosystem. Australia is not the only country to see this potential. Just across the Tasman Sea, New Zealand, home to more than 25 million sheep, has also begun testing similar approaches, with results arriving faster than many expected. On coastal farms where sandy soils are dry, compacted, and barely retain water, mixing in wool-based mulches helps soil moisture last 20 to 30% longer. In the basalt fields of the North Island, researchers observed a familiar signal. Within just a few months, soil microorganisms began to return. This is the earliest sign that the soil is no longer dead, but slowly regaining its core biological functions: water retention, gas exchange, and support for plant root systems. These results quickly caught the attention of New Zealand's business community. In Wellington, the startup Wool Chimney developed technology that turns waste wool into bio-based polymer pellets with exceptional water-holding capacity, opening up applications beyond traditional agriculture. Meanwhile, in Marlborough, the country's renowned wine-growing region, farmers using wool mulches reported up to a 25% reduction in irrigation demand during prolonged dry periods. What began as a local experiment is now steadily becoming a soil restoration tool capable of adapting to a wide range of ecosystems. In the United States, where sheep farming operates on a much smaller scale than in Australia or New Zealand, wool enters agriculture in a very different role. The issue here is not excess supply, but demand. More and more farms want to transition to organic farming, yet lack a stable natural nutrient source to replace chemical fertilizers. It is in this gap that wool emerges as an unexpected solution. In California, Colorado, and Vermont, farmers have begun mixing wool pellets into the soil as a slow-release nitrogen source. The results are both fast and clear. Within just 2 months, nitrogen leaching dropped by 15 to 22%, while soil moisture lasted 18 to 25% longer compared to control fields. Crucially, these benefits come without trade-offs. Wool does not cause nutrient shock, does not contaminate groundwater, and does not disrupt soil microbial communities, factors that are especially sensitive in organic farming. As a result, wool pellets have quickly been accepted as a rare, clean solution that meets performance, origin, and sustainability requirements at the same time. In the US, wool does more than improve soil. It has also become part of the branding story. Many farms now print the phrase "grown with wool pellets" directly on their packaging, turning a material once considered a byproduct into proof of a transparent and responsible agricultural system. From solar farm fields in the United States, the story begins to move beyond national borders. What is taking shape is no longer a series of isolated experiments, but a new way of thinking about agriculture in an era of increasing drought, one where animals, materials, and infrastructure no longer exist in isolation. Sheep are no longer valued only for meat or wool. They become part of a broader system of land, energy, and ecosystem management. Wool, once discarded, returns to the soil to retain moisture, support microbial life, and rebuild soil structure. Sheep, rather than being seen as pressure on grasslands, become precision vegetation management tools, often more effective than machinery. And systems once thought unrelated, from farms to solar power, begin to connect into a more efficient, more sustainable network. What is striking is that none of these models require breakthrough technology or billion-dollar investments. They rely on what already exists, repositioned within the ecosystem. As climate conditions grow more extreme and land faces increasing stress, these low-tech solutions are proving to be the most flexible and scalable. And perhaps the most important lesson of all does not belong to Australia, the United States, or New Zealand. It lies in a broader question. In a world running out of resources, are we overlooking solutions already beneath our feet? In the Sahel Belt, where the Sahara Desert advances by roughly 1 to 3 kilometers each year, More than 80% of farmland depends entirely on natural rainfall. A single prolonged dry season is enough to crack the soil, wipe out crops, and push millions toward food insecurity. The problem here is not crop varieties or fertilizer. It is that the soil has lost its ability to retain water and sustain life. A material that can hold moisture, break down slowly, and reactivate soil microorganisms, even at limited scale, can make a meaningful difference. In the Middle East, the pressure is even more severe. About 90% of freshwater resources are allocated to agriculture, while groundwater levels in many areas are falling by 0.5 to 1.5 meters per year. Any solution that improves soil water retention effectively extends the lifespan of entire farming systems, without requiring billion-dollar irrigation projects or massive energy consumption. What these regions share are harsh climates, limited resources, and growing survival pressure. And it is precisely in these conditions that simple, locally sourced, and scalable solutions prove most effective. Sheep wool is not a miracle cure, but in a world drying faster than humans can build infrastructure, it offers a different path: restore the soil before trying to save the harvest. This story does not belong only to Australia, New Zealand, or the United States. It reminds us that sometimes the answers to the world's biggest problems come from small, overlooked materials we once ignored. So what do you think? Can a single strand of wool really change the future of our planet? Share your thoughts in the comments below. And don't forget to like and subscribe to Mandarin Tech as we continue exploring more extraordinary stories together.